on graphing inequalities. So when you graph a line, it's in the form of an equation, and all of the coordinates on that line satisfy the equation. So if you punch them in, if you put them into the equation for x and y, the left side of the equation will always equal the right side of the equation. With an inequality, it's a region that is shaded or on the line, depending on whether or not it's greater than or equal to or less than or equal to. So you have more values that satisfy the inequality than just the line itself. So the first thing you have to do is you have to graph the line as an equality, and then you shade the area that satisfies the equation. So let's have a look at the first one here. So I am going to run through this very quickly. 4x minus 3y is less than 12. So there's our inequality. Okay, so I need to graph the line first. Now, we've done 3 methods in which you know how to graph a line. First method is change it to slope-intercept form. Second method is to just plug in 2 values for x, solve for y, and you got 2 points. The third one, which works here well because 12 is divisible by 4 and 3, all right, is use your intercepts. So that's what I'm going to do. So the first thing, if you remember, we change this to an equality. 4x minus 3y equals 12. Okay, so that's the first thing that we do so that we can graph it. Now, let's do this. X, y, put zeros in. 0 for x, that leaves us with negative 3y equals 12. What does y equal? Sorry? Great. Put a 0 in for y. That gives me 4x equals 12. What does x equal? 3. So we go to 0 and negative 4. Right here. We go to 3 and 0. Right here. And we draw a line. Okay. Is that line solid or dashed? Which is it? Dashed? How come? Right. Because there's no equals to here. Because there's no equals to, I have to draw the dash line. Yes, sir.
Like in the book, it says like, is less than negative 12. Would that change? Like you just the starting equation, like you have, is less than 12.
Mm-hmm. Okay, I'm going to get there. I'm going to deal with that part now. Okay. All right. So the first thing I do, I graph 4x minus 3y equals 12. I graph the line of it. Now I have to find a way to either graph shade above the line or below the line, depending on what happens here. So what do I do now? Yeah. Okay, so I pick a coordinate on either side of the line. Doesn't matter which. I like 0 and 0 if I can use it because it makes math easy. 0 subtract 0 is 0. Well done. 0 is 0 less than 12. Yes. Therefore, my solution set is every coordinate in that shaded area. So it doesn't matter what coordinate you pick, anywhere in this shaded area, it's going to satisfy the inequality of 4x minus 3y is less than 12. Yes.
What I meant was like that it says negative 12. Like,
does it say negative 12 in the question?
I understand the.
Yeah, that makes. Yeah. Okay. I wrote the question wrong. Yes, it does make a massive difference. Because if I put negative 12 in there now, then I'd be shading below that line. But, okay, so for what I have on the board, yes, you are correct. What you have in the book, yes, it would change things. Okay, so let's do a second one here. Any questions? We've done this, right? 2x minus 3y is 2x minus 3y greater than or equal to 15. Okay? First step is put an equal sign on it. Okay, so last time I used the intercepts. I can use the intercepts again if I want, but I'm going to have a decimal here. So I'm not going to use the intercepts. I'm going to use y equals mx plus b. So I'm going to subtract 2x. Divide by -3. And graph. Starting coordinate. Starting coordinate. You're not wrong, but I'm asking. Yes. Okay, you got to be specific on that. Did I ask for the y-intercept? No. That's -5. You're correct. Starting coordinate is the starting point that I need. So that is 0 and -5, which happens to be your y-intercept. 1, 2, 3, 4, 5. Right there. Where do I go from 0 and -5?
To the right.
Rise over run. So what does the 2 indicate? Up to. Over. 1, 2. 1, 2, 3. Solid or dash? Solid. How come? It's an equals to, right? Greater than or equal to. Now what do I do? Shade. Plug in a coordinate. So 0 and 0. 0 subtract 0. 0. 0 greater than 15? Yeah. Not my world. Not a part of the solution, 0 and 0, so we shade below the line. I would think math in general is going to be difficult if 0 is greater than 15, but we'll go with it.
When is it that when you shade the other, instead of shading like that, you just put points and then there's other?
Okay, good question. If I am given a, well, how about I deal with that right now in the next question. Sports manufacturer makes footballs and soccer balls. One football requires 4 minutes on the cutting machine, while one soccer ball requires only 3 minutes on the machine. Determine an inequality that would represent this situation. Draw a graph of the inequality to show that the number of each type of ball that could be made in 30 minutes or less. Okay. So, first things first, let's follow our book. I like how the book sets this up. Let X represent the number of which kind? There are 2, right? So we're going to go with footballs first or soccer balls? Footballs, thank you. Math and now English is an issue. School's a struggle. All right, requiring how many minutes? Footballs. 4 minutes, good. Y represents soccer balls. How many minutes required? To a maximum of how many minutes? 30. So 4x plus 3y is less than or equal to 30. Does it say? To show the number of each type of ball that could be made in 30 minutes or less. Does that show 30 minutes or less? Yeah. Do I need to include the equals to? Yes, I do. Okay, excellent. All right. Now, so to graph this guy, same idea. Let's do it again. 4x plus 3y equals 30. 3y equals -4x, add 30. Y equals -4 over 3x, add 10. Okay? Starting coordinate. Yep. Let's try that again. Zero and 10. Where do I go from 0 and 10? Down 4. 1, 2, 3, 4. Right 3. Solid or dashed? Solid. All right. Plug the coordinate in. Let's use 0 and 0. Is 0 less than 30? Yes. Last time I checked, right? However, to answer your question, which was a brilliant question, I'm a guy that can't do math or English. Can I have half a soccer ball, quarter of a soccer ball, a tenth of a soccer ball? I can't, right? So, therefore, when I do this question, X is an element of whole numbers, Y is an element of whole numbers. I am only talking about first quadrant as well because I can't have negative footballs or soccer balls. So to show that, rather than shading, I put dots on all my whole numbers. Okay. So when you're doing problems such as this one, that's where you're going to likely see more than not that you're going to be dealing with just first quadrant whole numbers only. Shading indicates that you're using all rational numbers, or all real numbers, which means decimals. By putting dots, you're talking about only whole numbers, values possible. Okay? Pretty good, not too bad. All right, and if you look here, what was the equation for that one?
4x plus 3y is less than or equal to 3.
There. What is the issue here? No dots, right? So you have to pay attention when you're doing the question. Oh, that's crazy. Have to pay attention to when you're doing the question that the Desmos will not give you the dots.
Are you able to like put it in there that
I don't know. I don't think so. I don't see it in there, James.
you just got it?
I don't know.
No, whatever. Wait a minute.
Oh, I didn't mean to do that. So yeah, I don't think you can. Okay, finish that up. I will hand back your assignments from yesterday as well in the next 8 to 10 here.